Hello. We've moved on to 4.2, okay? Talking about standard and vertex form, specifically completing the square. So CTS will be our short form. And today is Friday, May 1st. So our goals, make sure that you can do all three of these things and that you know what these three sentences or statements mean. To change vertex form to standard form, to change standard form to vertex form, to demonstrate an understanding of the phrase completing the square. So we've already talked about its short form, okay? So to complete the first goal, we've got this example. Expand. Name the type of equation in each example. So hopefully you can say, oh, that's y equals a, x minus h squared, plus k, that's vertex. Okay, if I'm going to expand, I'm going to take vertex form and get it into y equals ax squared plus bx plus c. Okay, and you should say that's standard form. All right, so let's review. Y equals x minus 3 times x minus 3. We've got two brackets, 1, 2. We have to FOIL. So we get y equals x squared minus 3x plus 9, and then minus 4, always following bedmass as we go. Okay, the reason that we're doing that is because y is already on its own side. Collect like terms, y is equal to x squared minus 6x plus 5. These are like, and these are like, okay? So that is standard form. Y equals ax squared plus bx plus c. Vertex form is here. So it's still in the form y equals a x minus h squared plus k. That's vertex form. And then just like question A, when we expand it, we get the form y equals x squared plus bx plus c. Okay? And when we do that, we're following bedmass, and we're getting standard form. So if this feels like a review, that's because it is. So 2 bracket x plus 1 times x plus 1 plus 5. Now, in paying attention to bedmass, we've got to do what's inside the brackets. Well, x plus 1 is not simplifiable, if that were a word. I just made that up. So x and 1 can't be combined to something else. It has to be separate. So we move on to exponents, which is what we had to do by expanding this, okay? So FOIL is what's required if we have two brackets and two terms in each. We have to FOIL. Y equals 2, x squared plus 1x plus 1x plus 1 plus 5, leaving the plus 5 out because we're just trying to follow bedmass. So bedmass says after exponents you have to do multiplication. Y equals 2, x squared plus 2x plus 1 plus 5, leaving the addition at the end. Y equals multiplication now. 2 multiplies to everything in the bracket. 2x squared plus 4x plus 2. Now you can add the 5. So y equals 2x squared plus 4x plus 7. And that's standard form, okay? Y equals ax squared plus bx plus c. The question is, if we can expand to move from vertex to standard form, how do we do the reverse? How do we go from here up to here? Okay, that's what 4.2 is about. Exactly this question, how do we go from here right up to here? Okay, so we've gone one way, that's a review, but how do we go backwards? Or how do we get from standard form to vertex form? Well, it's all about completing the square. And this actually is actually a square, right? Because it's a length of x minus 3 times itself, where the width is also x minus 3. So there's the length and there's the width. So if they are both equal, which they are, length is x minus 3 and width is x minus 3, and they're equal, that means it's a square. So what does it mean by completing this square? We have to take this and think about it algebraically, but we could also use the algebra tile method. So when we do that, we're going to write the standard form into vertex form by completing the square. Okay, we're going to use the algebra tile method. I've used a grid here. It's different from what we had in class. I've used the grid, hopefully thinking that, maybe this will help you. Okay, so let's do this. So I have to put x squared plus 6x. I'm going to focus on just the things that are containing the x. Okay, I'm not going to contain or do anything with this minus 2. I'm going to actually ignore it. Okay, so let's make x squared this shape here. Let's make it a square. Okay, so there's my x squareds. Okay, I have 6 x's. So when you have 6 candies, you give half to yourself and half to your friend. Okay, so if I take half of 6, it means that I have 3 x's on the top. Okay, so let's make this an x for the time being. So that's an x. Let's make this an x for the time being, and let's make this an x. Okay, and then this whole thing is x squared. All right. So if I have 3 towers, right, 3 x's in a tower form, then I'm going to do it sideways, and I'm going to go 1x here, so 1x here, 1x here, and another x here. Okay, so I'm representing this area inside my grid. Okay, because that's what it is. Now notice I've left the minus 2, so I'm going to put that we have a minus 2 here. I'm not using it in this piece because what I'm trying to do is I'm trying to take this and complete the missing piece to complete the square. And hopefully you go, oh, there's this great big gap here, and it's a 3 by 3 gap. Okay, I don't have any algebra tiles there. So what that means is I'm going to have to take from the math bank, I'm going to borrow 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to borrow 9 of these individual ones. Okay, they're always ones. So I always have ones. So we got rid of the dollar bills, but we've got loonies. Okay, so I need 9 loonies from my math bank to complete the square. So if I have them, okay, I also have a debt of what I've borrowed, right? So this is the 9 loonies in my pocket. I'm all right, but I have a debt, okay? I have a debt of what this is equal to. So I have a debt of 9, okay? So they gave me the minus 2, which was here, okay? And I have a debt of negative 9. This actually represents a sum total. I can add these, okay? So my total, I'm always going to add them. My total is equal to negative 11 because negative 2 plus negative 9 is negative 11, okay? That, believe it or not, represents the k value in my effort to complete the square. And you say, well, what does that mean? Well, if I go over here, okay, I have tried, this is my attempt, to go from standard to vertex. So my vertex form, remember I have a k here, okay? I have a k. This is actually my k value, okay? So my total is always my k value. What else do I have? Where does this come in? Well, notice that I had a 1 here, okay? Well, that 1 is actually my a value, okay? So that 1 is actually my a value, okay? So so I've taken care of my a, I've taken care of the k. Where is the x minus h squared? Well, it's found by breaking up this area into its dimensions. So here, that length, okay, that length is an x, right? Because this whole shape is an x squared. So if I break up an x squared, I have an x by an x, right? And then the short sides of my rectangles are always ones, okay? Now, it happened to be that I had positives here, so that was nice, okay, to start. So I have a positive 1 here. So positive 1 from here to here, another positive 1, and then I have a third positive 1, okay? So in total, I have x plus 3, which should be the exact same this way. So there's an x there, a length of x. These short sides are always 1. And when I count them up, I get a x plus 3. Now that should not be strange, right? Because I've completed a square. It means that my length and my width should both be the same value. So therefore, y equals 1x squared plus 6x minus 2 is equal to y equals, okay, y equals x plus 3 times x plus 3 minus 11. Well, that is y equals x plus 3 squared minus 11. Okay, so let's keep going. All right, so that is my vertex form. Now I'm only doing 2 examples, so if you need more examples, I can share another YouTube video, one that I can find on YouTube. Okay, so how do I do it algebraically? Okay, so I notice that there's an a equals 1, okay? So I want an a equals 1, okay? So I'm gonna rewrite that, and I'm gonna rewrite this. So I've always rewrite my first and second term where a is 1, okay? So a is 1, so therefore rewrite ax squared plus bx, okay? And then second, I want to find my c value to complete, c is for complete, the square using b divided by 2 squared. So my b value is ax squared plus bx. My b is 6. So c is equal to 6 divided by 2. Remember your 6 candies? Put them into 2 groups for you and your friend. C equals 3 squared. C equals to 9. But because I never had the 9 before, I'm going to not only need it to complete my square, but I'm going to have a debt of that. And that was the same thing that I said in the algebra tile method. So these numbers I put over here, okay? But I'm going to have to move everything because now I don't have any room. Okay, so I rewrite my 1x squared plus my 6x, and then what I have here is I have my plus c value of plus 9 and my minus c value of minus 9. And then I just rewrite my minus 2. Okay, those are my c values. Now, c is what was needed to complete the square. Now I factor. So I say, okay, a is 1, so that means all I have to do is find what multiplies to 9 and adds to 6. Well, what multiplies to 9 is 3 and 3, and 3 plus 3 is equal to 6. So y is equal to x plus 3 and x plus 3. Okay, so the third thing is factor ax squared plus bx plus c. Okay, so I want to factor it and then add the terms, add the end terms. So that's negative, look at that, negative 11 is the number we had. And add last two terms. Okay? And then the last thing is to shorten it up, and voila, we have vertex form, and it matches. Okay? Alrighty. Let's move on. What if, though, there was an a of value of 3? Okay, it causes me a bit of problem here. I could only make one picture. I'm an artist, I make the originals. But I need to duplicate this 3 times if a is 3. So I want to divide ax squared and bx by the a value. Okay? So a is 3. Okay, a is 3. Therefore, ax squared plus bx is divided by the a. Divided by the a. So we're going to do that in this algebraic side. So we divide. We don't do anything to this plus 1. So y equals 3 x squared minus 4x, and then plus 1. Okay, now I take this and I put it over here. So I say that a is 1. Okay, so a is 3. Oh my goodness. A is 3, right? But I take my x squared and my 4x and I make that over here. Okay, so x squared, let's make a squared here. Okay, so that's my x squared. Now remember, I have candies. I divide them into 2 groups. So negative 4 divided by 2 is negative 2 here. Okay, so that's a negative x there and negative x there. So that's negative 2x, right? And then over on here, negative x here and negative x here. Okay? Now, I have a plus 1. So I'm going to write that over here. So I have a plus 1. I never use that. I don't care about that. I ignore it. Okay? I have to complete the square here. Well, if I complete the square, I can see that what's missing, okay, is 1, 2, 3, 4. 4 little ones. Okay, so I go to the bath bank and I say, I need 4 loonies. So I need 1, 2, 3, 4. And the banker or the teller says, why do you need these? And I say, well, to complete my square. Okay, so if I get the 4 loonies, okay, the teller says that's okay, but in your account, we'll say that you have a debt of 4. Okay, there it is, but you have to eventually pay it back. And I say, oh, that's okay, because my total in my account is positive 1 minus 4. Oh, I really only owe you negative 3. And in math terminology, that represents my k in the vertex form. What else do I have? So I have the negative 3 as my k. My vertex form says I need a bracket which is identical to the dimensions of the length and width. Well, here we go. There's an x from here to here. The short side, if the tile is negative, the short side of a rectangular tile is always going to take the negative of it. Okay? So the negative 1. It's always going to take the negative sign. And this is identical, negative 1. So if you're trying to find a pattern, this first thing will always be x, and then these other numbers along the top are going to always be just 1s. And then in total, you have an x minus 2. Okay, so then you say, oh, well, I should have an x minus 2 on the other side. So here's an x, okay, there. And there's this the short side, but it's negative. And this is also negative. From here to here, it's negative. So then equals x minus 2. Okay, so then in total, Those are the things I circled. Those are the things we needed. Okay, so therefore y is equal to, I thought of something and I realized I forgot. Okay, so let's stop for a second. Remember how the a value is 3. Okay, remember how the a value is 3. So although this is my original masterpiece, right, my original completed the square, that actually has to be made in triplicate. Why? Because a is 3, triple. So my debt is not just -3. Good thing I used pencil. My debt is -4 times the a value of 3. So my debt is actually -12. So if I rewrite that, let's watch what I do to make it more visible, more understandable. So what I have was the +1, okay, and my debt was my 4 times my a value of 3, okay, is equal to -12. And then if we line these up, right, if we move them over like in a column form, right, if I line them up, then overall I have a -11. Okay, and that's my k value as my total. Now, you might be a little skeptical, okay, an unbeliever, okay, to see that that makes sense, but it's okay. We'll figure it out and we'll prove it. Okay, so right now, this question gets rewritten. So y equals 3x squared plus 12x plus 1 becomes three groups of x minus 2 times x minus 2 minus 11. Okay, so y equals 3x minus 2 squared minus 11, and that's vertex form. Okay? Okay, so let's see if it works over here. So that's my answer. Okay? That's my answer. All right, so over here, what do I do after I take out my a value when it's not 1? I have to complete the square. So my first thing was to divide my first and second term, the ax squared plus the bx, divide it by a. Okay, so that was my first thing. Okay, my second thing is to find c.